Hello and welcome to Qubit Networks Tech Talk for April 2022. I'm Josh Mandeville, the CTO of Qubit Networks. This month I have Brook Moore, a senior solutions architect with Extreme Networks. I've been working with Brook for a few years. He's helped me out quite a few times, and I'd say he's one of the smartest guys around. So, how you doing today, Brook?
I'm doing good. How are you?
I'm doing good, except for like we talked a little bit beforehand.
Yeah,
Surprised by the snow on the ground today in
happy
mid-April, but
Easter.
yeah, hey, keeps life exciting. Can you tell me a little about yourself and maybe a little about your path to where you are with Extreme Networks now?
My path is fun. Coming out of high school, the last thing I wanted to do was go to university, so I went to the Navy, thinking, initially I was supposed to be a ballistic missile technician. I got to sub school, and that was not for me. So, kind of banked out of that and went down what was called at the time an FTM, so fire control technician, missile system. So I worked on radars. And long story short, as I got near the end of my naval career, the 6 years that I was obligated to go in, they introduced computers onto the ship I was on, and I started playing with the computers. I actually became the computer guy in our department. And lo and behold, coming out of the Navy looking for the appropriate job, I got one at NASA Langley Research Center in Norfolk, Virginia, or Hampton, Virginia, actually. And I started connecting the Sun Microsystem 2 computers to ARPANET. And I'm
That's
sitting there
awesome.
going, the joke sometimes when I talk about this is, Al Gore was next to me doing vampire taps and whatnot because he invented the internet. But nonetheless, I was part of getting ARPANET up and running with NASA talking to actually it was Berkeley was one of the major communication paths that they were doing because they were I had a top secret clearance, so that was one of the reasons I got hired, and I was able to work on the F-20 Tiger Shark fighter plane in the wind tunnels, and I was able to be in there and make sure the computers and everything were working and the communication path was going, so they could take those data points and throw them back to Berkeley and a couple of other universities. So it was pretty neat. Pay was terrible because it was NASA. They're not going to pay anything because you work for NASA, but it was
Right.
great experience.
Oh, for sure. That sounds awesome.
So that's how I got introduced to, DEC PDP-11s, which were the routing entity back then for ARPANET. A lot of the routers they were the Cisco or DEC PDP-11s, these big mainframe servers. So I went from there, got into routing, started working with a customer that was doing Wellfleet gear. And so I started getting into Wellfleet routing. Moved to the Chicago area where I was a director of technology, had all Wellfleet and Synoptics gear, which was funny because they merged to become Bay Networks. And it just kind of blossomed from there. Stayed in the networking environment, got my Bay router expert, got a couple of other certifications. Started working for a couple manufacturers. I started with Avaya, went to Enterasys, kind of back to Avaya Nortel, and then Extreme just kept buying these entities up, and here I am at Extreme all those
All
years.
right. This Extreme bought Enterasys and
And
Avaya
Avaya,
networking.
yeah. So I
So
left the
that
year before Extreme bought Enterasys, and then I was at Avaya when Extreme bought Avaya. I'm like, I can't get away from these guys. They're buying us. So
well,
here
good
I
for
am.
us, right?
Yeah.
That's an
Well, good
awesome
to still
path.
fully employed. Yes.
I bet you have a lot of stories that you can't tell.
There's some. There were, yeah, there were some things that happened in the Persian Gulf I'm not supposed to talk about. I think it was for 20 years. It might be 20 years by now, but it's just it's some
Better.
weird stuff happens when you're out there. Yeah,
Yeah, I'd rather not have Secret Service show up at my door.
yeah,
Like, sorry, you can't air this video.
yeah.
um, so the reason I had you on is I find you one of the experts in extreme fabric networking,
Thank you.
and we hear that term a lot these days, quote fabric, and I know Extreme got theirs from the Avaya purchase, but
Correct.
like I think a lot of people don't know what they just see the buzzword, the marketing term fabric, and don't quite know what it is. So I guess what is it, and what are the key benefits and takeaways from Extreme fabric networking?
I mean, if you look at the raw term of fabric, what it is you're taking a disparate switch community and making it act as a single entity, right? So you can look at IP fabric, which is your kind of go-to in large, like Amazon or Google data centers, where they have this massive amount of switching architecture and they work in an IP fabric. They're using BGP routing to kind of condense the infrastructure and make it act as a single unit so that when one unit does something, the rest of the units know that that happens. In a traditional switching environment with VLANs and tagging and spanning tree zones and all of this other stuff, that doesn't happen. One switch doesn't necessarily know what another switch in the other side of the network is doing. In fact, rarely do they know what's going on unless there's a VLAN tag
Right.
running through to them, right? So in a fabric architecture, we've kind of taken it to where you have a VM, a virtual machine world where I've got 5 servers running on one physical CAN. Well, what we're doing in the networking world with fabric is we're taking those 5 physical CANs and we're virtually making them a single entity. And it can be a minimum of 3 switches to make a fabric, as many as, depending on the switch architecture, 2,000 nodes. So they can be pretty large. And then we can get into multi-fabric areas where we can have multiple fabrics communicating with each other when we increase beyond what's called the nodal count. And that's determined by your least capable switch in a campus
Okay.
fabric solution, right?
Okay.
So if we're looking, like say in the extreme world, if we put a 5300 as one of the fabric capacity switches that's running native campus fabric or SPB, shortest path bridging, then we'd reduce our nodal count to 256 nodes, which is still a fairly large network because a stack of switches is a single node and a stack of switches
Okay.
actually is going to run as fabric attached because, as we say, fabric engine or what used to be called VOS does not stack.
Okay.
So 512 nodes or 256 nodes is still quite a bit. If we then move up to the 5400 line, we've got 512 nodes of nodal count. And then we get, as we get into the higher switches like 7400s, if I've got all 7400s, I'm looking at over 2,000 nodes that I can put into an infrastructure, which is fairly large.
Now,
We have some,
does a
what's
fabric
that?
attached switch count as a node or a
It does
stack?
not. A fabric
Okay.
attached considered an external device. It's doing LLDP communication. It's not native fabric. So I'm not what happens is the biggest difference between a campus fabric solution that's running SPV and an IP fabric scenario is the memory utilization, right? So in an IP fabric scenario, you have to have these massive switches with massive memory buffers because I've got all these BGP routes going on, and my tables need to be able to handle all those BGP routes, and it needs to be able to figure out where I'm going. With a campus fabric solution, SPB, shortest path bridging, we're using ISIS. And ISIS, in the realm that we're using it for Extremes campus fabric, we have a primary and secondary path predetermined on boot. So that boots up, it determines what's my primary path, what is my secondary path, and I've got that Dijkstra algorithm already running for both of those. Difference,
Okay.
like, so say an OSPF routed infrastructure compared to fabric, is I've got my primary path built and running with OSPF. When that fails, I have to run Dijkstra to figure out what my next fastest route is. ISIS already knows that. So I have a failure, I immediately fail over to my second one. Now I'm running Dijkstra in the background to figure out what's my next secondary. And
That
the
becomes your
SPV,
primary. Okay.
yeah.
Yeah.
So it's built in and ready to go, and that's actually one of the reasons OSPF won back in the 90s because ISIS and OSPF were two of the interior gateway routing protocols that were competing for market share. If not that they get paid for it, but
Right.
OSPF can run on a lot less memory because it doesn't need to bank that secondary target of where it needs to go. It does it for the first one. Oh, there's a hiccup. I got to run Dijkstra, and here's my new primary, right? So it uses
Right.
less memory. And memory in the late 90s, early 2000s was very expensive. So ISIS, being that it could do a primary, secondary, tertiary, and actually a fourth route, is built into the ISIS protocol. You can chew up a lot of memory by holding what are all those paths, but the failover is just instantaneous. Like you can
Right.
be in the middle of a call and not know that you failed over in an SPB environment because of that.
And as switches have gotten more memory and
And,
has
and
become
memory,
more prolific,
I mean,
it's
we're
being yeah.
throwing most of our switches. I believe we're throwing 128 or no, a couple of gig of RAM, 8 gig of RAM in there, 8 or 6
Geez. Wow.
compared to 126 meg back in
Right.
2000. Right? It's just exponentially massive comparatively.
I understand then that's why OSPF won back in the 90s and why SPB is now kind of taking a it's starting to win, I guess.
In a lot of cases, yeah. I mean, we've definitely got some use cases out there where they've had an OSPF routing infrastructure. They they take a section of it and they put SPB in there, source path bridging, the Extremes campus fabric solution, and they use it. They go, holy crap, this is 10 times easier to one implement, also to troubleshoot, and to see where the packets are going. You can do trace routes on layer two within the ISIS environment. And that's one of the other powers of ISIS is extensible routing protocol, which means I can do layer two routing on it. I can do layer three routing on it. I can do IPv6 routing on it. And I can actually do layer four routing within an ISIS environment where I can make decisions on the routing algorithm depending on the TCP or UDP port that's being used, source or destination. So very powerful routing protocol.
Yeah, and my first experience with it, I was pretty amazed at it, and I was like, it's a I thought of it as I almost had to go backward.
And I find that very interesting. If when I do campus fabric classes, and I know I did one for you guys when we first got purchased, and we went over there and showed you what campus fabric was. The campus fabric classes I've done, the guys who are Microsoft certified who aren't strong on networking, they pick it up and get it because the
Yeah,
guys
for
that have
sure.
done networking for years are going, you're making me relearn this crap. It's different than we've ever done it. And it really is. We've
Yeah.
changed the way that you network.
Well, I think we all had a push to get to layer 3, like an OSPF
Oh,
or
yeah.
in the
Yeah.
Cisco
Layer
world,
three to the edge.
EIGRP.
Let's route because the switches can do it. So let's route there. That was
Yeah, but we just did it that way, and now this newer technology and SPP is isn't it a lot newer than OSPF, right?
Well, yeah, SPB was actually ratified in, I believe it was 2013, 13 or 14.
Yeah,
802.11aq was ratified. And I mean, OSPF was,
in the
well, version
90s.
4, right,
Yeah.
was 2002-ish. Now
Okay.
we've got OSPF version 6 because of IPv6. And there was obviously OSPF version 3, 2, and 1, which go back into the 90s.
Yeah.
But yeah, I mean, it's a much newer, protocol utilizing Ethernet as the base of it, and
Right.
utilizing protocols that were already there that had already been developed. And I mean, it's funny because it is a new protocol. It's using older protocols, and while it's a great solution, obviously it's not the perfect end all be all. There are some limitations, right? Nodal counts because it does take memory. So if you've got the 5300, like I said, with 8 gig of RAM, there's only so many devices I can store
Right.
primary, secondary, and here's how I get to everybody because it does have to hold that information. And then you get into the other, what I would consider, caveat, something you have to consider is that it is a point-to-point protocol. You can't do point to multi-point. If you have multiple points, like in an MLSP, or, some sort of WAN that has, like a hub and spoke where I've got multiple sites off of a single entity, I've got to create those defined point-to-points within that because it has
Okay.
point-to-point protocol.
Okay.
So there's those kind of caveats with SPB, right?
But it inherently will do ring, like
Oh, absolutely.
just
And,
built in. You don't have to run a ring protocol on top. It's built in.
right. So, and that's one of the things I like to talk about with customers when they want to look at, well, why would I want to go with Campus Fabric? I've got Spanning Tree. It helps me with building rings and loops and stuff like that. I said, well, so the funny thing is, Spanning Tree was not invented to be a ring or loop protocol. It was invented to stop the loops from happening, right? Just like
Right.
VLANs are not a security container. VLANs were invented to be a broadcast container, and that was their job. People modified it and said, hey, look, we can be a security container. Well, maybe a little bit.
Yeah.
But Spanning Tree was not built to be a loop protocol. It was built to stop the loops. Whereas if you look at shortest path bridging, it was built to have rings, to utilize those rings, to simultaneously use all links that are active all the time. So it's not sitting there blocking a link. It sees two paths. It goes, hey, I've got two paths. I'm going to send even down here and odd down here so I can load balance between those two paths. And it
That's what I
understands,
love. I
yeah,
love that because most ring technologies you're blocking somewhere.
yeah, you're absolutely. I mean, even the ones that were built to be redundant ring
Yeah.
protocols, like ERP, right, with
Yeah.
the stream invented and now a standard, it was meant to have one blocky path. It knows that there's a ring there and it wants to have it, but it can't utilize it. Where shortest path bridging actually uses those links.
I think that's a super important point when you're talking high bandwidth and when you want short redundancy to kick in. I've seen a lot of cases where OSPF networks can take 15, 20 seconds before the that path
But
kicks in.
because
And
if the spanning tree fails on the bottom,
yeah,
everything
exactly.
below that has to resolve itself before OSPF can do Dijkstra and return to passing data. And when you get into, for me, shortest path bridging, the sweet spot is higher education is a killer, right? It goes in there and they're like, well, I could do more with the same amount of people I have. And that's a huge thing because their staff is always limited. But when you go into these city ofs where they've got fiber runs this direction because that's where it is, shortest path bridging eats that up. I'm not sitting there cross patching it because I can't do that type of connection with a traditional
Right.
network. Shortest path bridging says, yeah, there it is. It's fine. We can keep
Yeah.
going. You don't have to cross patch me, right?
That's
It's really powerful in the way that it can just meld to how the network is built and not how it, you have to do it because that's how we've always done it.
right. And I think a lot of people out there would be interested in seeing a demo of it. And
Yeah.
I would encourage you to get a demo because honestly, you hear this and you're like, yeah,
Yeah, it's all
okay.
bullshit, right?
Yeah, right.
And I get that every time I walk into and do an on-site class, and we're actually going to be doing one here in this quarter in the region.
Okay.
Um, every time I get into the class, about halfway through it, I've got one or two engineers that go, when I walked in here, I thought you were full of crap. That there's no
Yeah.
way that this protocol does everything that you say it does. And I'm looking at this going, holy crap, he's not lying. This is
No,
doing.
right.
We try not to over exaggerate what it
I'm
does,
I'm
but
one
there's
of
so
those
much.
guys. I'm one of those
Yeah,
guys. I can testify. I got in the class and I'm like, yeah, I've heard
yeah.
stuff like this
Oh,
before.
APM's
And
gonna
then
solve all your problems. Fitty is it's
yeah,
the savior of all networking.
right.
Token ring's gonna be the end all be all. Well,
Yeah.
here we are.
Here we are. And I say when I implemented it in the class, I was semi surprised that it worked as well. That it
Yeah.
worked just like you said it was going to. And I was like, because I've had been in classes where there's bugs and you're like, oh well, if we got to do this, fix it. And we didn't have to. It just worked. It was great.
Oh, believe me, when I first went to Avaya, and it was so much more limited when I first went there, and I went there because of Fabric, right? I
Yeah.
left in Terraces to go to Avaya, and they only had it on their 8800s, which were their core chassis boxes. They were coming out with a new core chassis, the VX9K, that had Fabric on it as well, but it wasn't released yet. So when
Yeah.
they were talking to me about this through the interview, I'm going, well, it sounds fantastic, a little more than fantastic. If it does half of what they say it's doing, it's a pretty awesome little protocol, and this has got legs, right? So I'm like,
Right.
okay, I'll go ahead and take the leap. And I, like you, I went into that first class going, holy shit, this is doing everything they say it's doing, right?
Right.
So, and then I mean, I had the luxury of sitting down and having Paul Ubenhagen go through Fabric, where it came from, where it was, and where it was going back in the day. And it's just awesome seeing him speak to what it could do. So it pretty, and even I had that holy crap moment of it's really doing everything they're saying it's doing.
Right. Yeah. I mean, it's a great protocol. Um,
Yeah.
this is great information. This is a great overview. If anybody out there wants a deeper understanding of it, get a hold of us. We can get you in touch with Brooke. We'll get you into a class. We'll get you into a demo and let you get hands on in Extreme Fabric so you can see for yourself that this really does work and can solve quite a few problems.
Yeah, and one of the biggest differentiators, if you look at an IP fabric or you look at any of the other fabrics that have been out there, they are a data center fabric play. That's their point. That's where they reside. That's the end of it.
That's what they're
With
for.
with a campus fabric solution, we go from the data center out to the edge. If you have 2,000 servers and switches and whatnot in your data center, it might be too big for a fabric. It's something we can look at, but
Sure.
90% of our customers don't have that.
Right. Yeah. 2,000 servers is quite a few.
Yeah.
um, no, that's awesome. Well, thank you very much for coming on and explaining this in
My
more
pleasure.
detail than I could. So thank you very much and have a great day.
All right, you too, Josh. We'll talk to you soon.
Yep, sounds good.